Dear ladies and gentlemen, a warm welcome to today's webinar, Servo Presses, Efficient Force Displacement Monitoring and Process Control. I'm looking forward to give you within the next 30 minutes an overview about our services and products with our Kistler Servo Presses. We call it also NC joining systems here. If you have any questions, please do not hesitate to post your questions in the chat section. We try to answer them at the end of the webinar or afterwards individually. At the start, some words to my person and my background. My name is Alexander Miller. My basic graduation is an engineer in mechatronics, followed by an MBA of international marketing. I've been working for more than 15 years in different functions like engineering, project management, and product management in the businesses of servo presses. I collect many experience in products, applications, and on customer side, and looking forward to present you in that webinar an overview of what we can offer for you and how we can support you with our service and products. First, I want to begin with the challenges you have in different industry, independent where you are coming from the automotive industry, medical industry, 3C market, or white good, or whatever. There are a lot of topics you have to consider and which challenge you. First one is for sure cost reduction. Everyone has to reduce the cost. You have to cut the operating cost. You have to take care about energy efficiency for sure. You have to take care about low maintenance operation, and for sure quality is important. You have to ensure 100% quality of your products. The other point is you have to take care about the productivity, the output. The process must be reliable and stable, and for sure you are trying to shorten the cycle times of your process. And the other thing is we want to take care about our environment. So these are typical challenges we have to take care. And if you think now about your application, you have your challenges too. You have different applications, like for example, you have a press fit operation, some caulking, riveting, clinching, or perhaps you have to test some springs or other applications too. And at the beginning of a project, sometimes you don't know how I should do that. What is the challenge? I can do a lot of calculations. I'm really sure how the process looks like. Is it from a theory point of view, really in the practical point of view, the same? And for sure, if you plan something, you want to reduce the risk and find the perfect solution. For that, we stand for. We as Kistler have decades of experience in these kind of application of force displacement monitoring of our servo press systems, and we want to take the challenge and help you to find out what is the best product, service, and solution for your application. There are different kind of phases we can support you to do the right things for your project. At the beginning, I want to start with the planning and consulting phase. Here in the planning and consulting phase, we have our experts, and you can benefit very strongly from our experience in the past and of our applications we have done. Let's take a look at that. Our experts, they are in the department it calls JCC. It's the Joining Competence Center. So there are experts with decades of experience of this application, and they know exactly our products. What are the special things or special properties and features of our products? And for sure, they can help you to find the right product from Kistler fitting to your application. That means if you know your cycle time, you know approximately about your application, what could be the joining stroke, what could be the idle stroke, what force you really need, what is the stop condition. If you provide us these kind of data, we can put it in our own programmed simulation, and with our own programmed simulation, we have a possibility to predict really what will happen. Is there any limitation of the lifetime of a spindle? Is there any limitation of a servo motor or some other things happen, and we can predict too what is the real cycle time. That helps you and reduce the risk during commissioning. And if you don't know exactly the force, we have other possibilities too here. We have different test stands like that one here in our production center in Lahr. And you see we are very flexible here. We can mount different kind of joining modules. We have a flexible frame here that we can easily move up and down. We have a large space for bigger parts, and so we can do the test. So if you don't know exactly what kind of force you need or how your process looks like, we have a possibility to do that for you. And then you can make a combination like a worst case combination. We can check what is the force for that and how the different curve looks like. And so then we can select the right system with the right force capability here and to offer you the best solution for that. That means if we know now application, the force, cycle time, and all the requirements for your application, we have different kind of products which offer different kind of features. This means our force range begins at 50 Newton, this is the smallest one, and ends up at 600 kilonewton. If you compare these two mechanic systems here, you see that's the smallest one, and that's the real big one here, 600 kilonewton. And now it depends on your application. The NCFH, the name is for numeric control, F for fügen, it's for the German word for joining here, and H for hollow shaft motor design. You see, this kind of units has some advantages that they have a very compact design because the motor is built around the spindle, and so we get a direct drive and a high dynamic. With an integrated piezoelectric load cell, we can switch between measurement ranges and have here a high accuracy. This means this is the most expensive one, but has a lot of advantages for you. Then we have an NCFN model. It's based on strain gauge, and you see it's like that. We can flip the motor. We have different strokes, so it's it's very modular, and we can do a lot of adaptation for your process too. And we have the cheapest one. It's an NCFE, E for economic. It's a strain gauge based joining model, and that it's perfect if there is a easy or a simple joining application with a lower budget for that. And which one fits to your application or can fulfill your application? We can calculate, simulate within some minutes and give you a fast feedback, which one you should use for your application. So to have a short summary, the takeaways is the tests in advance. They help you, which we offers to learn more about your application if you don't know it. You learn about which kind of evaluation functions are required, which force ranges, and so on. Our simulation, a real simulation, really helps you to ensure and to know the lifetime and the cycle time. And the important thing is we do the simulation with the real parameters of the servo drive. So that means if the cycle time fits not to your requirement, we can adjust our simulation that we know in some minutes, okay, if we adjust the control parameters, okay, we can reduce the cycle time by X milliseconds, whatever. And for sure, the pre-tests and the simulation, if you do that at the beginning, it really helps you here to avoid any problems during the commissioning and helps you to select the best value for the price. So if we go now to the commissioning, so here it's important for sure time to market. If you know exactly which kind of system you need, we can offer you the system, and the system we can supply you within several weeks. And important for that kind of system, if you get the system is pre-tested. That means a system, if you are talking about a system, which consists first from the joining model, it's the actuator level, including a force sensor and a displacement sensor. On the control and monitoring level, we have a servo drive, which is controlled by our Maximus NC, which do the control and the evaluation. And we have a visualization and interaction level here, like the DIM or any kind of PC where you can use, for example, an VNC for visualization. So the advantage is here with our Maximus family, means Maximus stands for Maximum XY Monitoring System. And the NC means it's with an integrated numeric control for the servo drive. The TL means it's the top level. If you have any kind of actuator where you don't need any kind of NC control, you can use that device too. And the advantage is here, if you use that, you can also do a visualization with one DIM of several of these devices and have also a kind of dashboard. And these kind of devices, they are typically connected to the PLC. Then you have a direct control by the PLC, and the data, process data and evaluation data or the curves can be exported to a server by an Ethernet. We call it not force displacement monitoring only, because Maximus means also we can use a torque sensor. So X is the torque and Y is the angle. And if you need a cheaper solution for that, with the various limited features necessary, we have a BL, a basic level device too. And the good thing is, if you know one of these devices, it's quite easy to learn the other devices because the look and feel, because it's one family, is the same. So the advantage of our system with a Maximus NC is you have a sequence editor. This means you can control the process quite easily. At the beginning here, this is a quite easy program. This means you set that up with on the left side any kind of elements. They are described here over there. And to explain you a very easy, simple process, which you can do the parameterization in 1-2 minutes. This means first you have a label. This is the start. Then you go with an element, start the measurement. Then you have an idle stroke to 100 millimeter. Then you have the joining stroke. The other settings are on the right side. Joining stroke to 120 millimeter absolute with a speed you set up. You have a jack for maximum force. You stop at a force condition. Then if you have done that, you have a settle time. You will wait for 500 milliseconds. Then you stop the measurement. Then you get the results, and then you can decide to go to a home position and the sequence, and that's it. That's all for an easy, simple joining program. And if you want to do any modification, it's quite easy. You have to click in, change the position, change the speed, change the force. That's it. So this is easy. If you get really very complex application, so we have a lot of powerful other elements too. We can make an interaction with the user, with a dialogue. We can calculate any kind of values. We have a wait element. If you make an intermediate position, wait with a PLC there, and then you start the joining stroke here. You have if conditions, you can jump, you can make any taras and offsets, and you can scan a barcode too here in the sequence. So all these things are possible. One major important thing is our motion element. The motion element is very powerful. The motion element can stop at an absolute position, at an absolute force, at a relative force, at a relative position. It can stop or make a force feedback control. It can stop by an external signal. It can stop by a gradient and what else? Yeah, there are a lot of things you can do. So if you have a more complex application or in advance, you don't know you really have that, you have a possibility with our device to do that kind of settings, and it helps you to find a solution for your process control. For sure, the control is one thing. On the other hand, you have a monitoring. So if you have any kind of curves, we have really a powerful evaluation device here. You see here, there are some special ones. We have a possibility with an integral or gradient or an average, but we have also with a real-time curve here, we have also the possibility here to control it in real time too. That means if you use some kind of special evaluation objects like the tunnel box here, if you are in a not allowed area, the spindle will stop, the joining system will stop immediately. So if a wrong part is in or something happened, you can stop. If you want to stop at the block position, we have an evaluation object which detects the block position and will stop when you have reached the block position. Or if a tool breaks, you get a real-time signal, the spindle stops, there's no more damage, you go back and can fix it. So you see we have a lot of, how to say, advanced functionality too, beside some, how to say, simple evaluation objects. So, and to have an overview here, you see typically we have an uni box, we have an envelope curve. We can also do very complex evaluations. That means we have a get ref, we can find any kind of gradient, any kind of special reference points. These reference points can be used with our EOS that you can do a positioning of them relative to that point, not only absolute, you can do a positioning relative to the endpoint. So you have a lot of different things you can manage with our device here. So, and these are things which were developed in the past on existing application which really required that kind of functionality. To summarize that benefits during the commissioning, you have an advantage if you buy a system. Here a servo press from Kistlom. Sure, we put everything in our production. We make a complete pre-test of a system, and it's more or less a plug and play. So because we have done all the setup of a system, that means you get in the scope of delivery, you get a safety protocol, you get the calibration, you get a system overview, calibration certification of a force sensor. Everything is done. So for sure also the safety. Then the other thing is you have advantages that we can offer you a complete family for the XY monitoring. It's not only servo press, so if you have other force displacement or any XY monitoring, so we have a complete family and it's the same look and feel. So you only have to learn more or less one family and that's it. And with the product, we can cover this application. And for sure, it's easy to use our system, but if there is something required, which must be flexible and you need powerful functions like powerful control functions or monitoring functions, don't care. We have it on board in our device. Okay, now we have done the commissioning. The next step is production and operation. So that means here, typically, if you have installed joining module, we press in, for example, here, any kind of bearings in the housing. And for sure, our system guarantees here, if you press it in, that you are in the right position and you have your right force. If something happens that a part is not the tolerance, we find it out. We know, okay, that part is not okay, and you can decide what you want to do with that kind of part. That's the way how our systems work and are in operation. Now we have something we call it free RCTN. So it looks like a little bit mathematics, but I want to explain you what it is. The first one is the first R for reduction of carbon footprint. This means you have an advantage using our technology and our systems to do something good for the environment and to reduce the carbon footprint because you save electrical energy. The second R is for the total cost of ownership. This means it's easy to handle our systems, whereas not so many maintenance like other technologies, so you can save time and money here by using an electromechanical joining system. The third R is because of a better control, it's possible that you can improve OK parts and you have not so many NOK parts, which saves you money too and resources. So if you see here now 3R, 1R for reduction of footprint, second R, reduction of total cost of ownership, and the third R for reduction of NOK part, then you have the 3R and the C for carbon footprint, T for total cost of ownership, and N for NOK parts. If you go to the first R now, for sure the carbon footprint looks like that. Most of you know that. For us, it's important the electricity here. If you think about the electricity, what can we do here to improve the carbon footprint by electricity? we do not need so many electricity like other technologies. So, and that's why the University of Kassel had done some test here, some benchmark, and they have moved a weight of 100 kilogram in a first shift operation in 6,000 hours a year. And then they measured what is the power requirement for that. For the pneumatic, they need around about 8,400 kilowatt hours, the hydraulic 3,600, and the electromechanical system needed only around 820 kilowatt hours. So, and if you calculate that in carbon footprint, so it's really possible here to save, as mentioned before, the 2 tons carbon footprint, 2 tons CO2 every year. So if you see the electricity which you can save here, it's for pneumatic systems up to 90%, but for sure, this was one test. It really depends on which kind of technology, how you use the technology here, and how your application looks like. But you see here, university in the test, there is a huge potential here to save energy and improve the CO2 emission by the technology of electromechanical systems. The second R is here we have done an own calculation here. If you provide us the data of your existing machine, we can make a calculation. What can you really save? There's one cost block for sure. The first cost block is the energy cost. As mentioned before, this is something what you can save. But for sure, there are maintenance, material costs, space costs, and other costs too. If you have here an example, for example, with 5 pneumatic systems here, you have energy costs roundabout of the 2 systems, depends on the application for sure, of roundabout 9,700 euros. The electromechanical system needs only 720, so you have savings around about 9,000 euros for that. The maintenance cost, our system has low maintenance cost. The calibration for application once a year is in general enough. And so you have also here possibilities to save additional money. And if you look at the total cost of ownership here, it's possible here to save for these kind of 5 systems and application up to 9,000 euros a day. And you do something good for the environment too. For sure, that's why it's important. It's only an example. If you have your real data about your application, you can provide it to us. We can put it in our program and we can calculate what are the real savings we can offer to you using our products. And the third R is the advantage is we can control the process. So that means it's quite easy here to do the programming, and that means if you have an idle stroke and you have a high speed of idles of 200 millimeter per second because you want to save time, then the pressing, make a soft touch here and do a pressing with a lower speed, and then you go back, you need some time for that, for sure. But if you have a quite easy system and have only the possibility because of less control possibilities, only one speed, so you have to find something between what is an idle stroke speed and what is the joining speed. And typically, if you go with one, you don't want it make it too slow because then the process is too slow. And so it could happen that you get some peaks because you hit the part with a higher speed. So, and that we have some customer that if you do it like that, get more NOK parts. So that means they save money instead of using these kind of systems, our system here, and so they had the possibility to reduce the NOK parts by the better control and the easy programming of our system too. To have some key data of our Maximus NC here. So this device, the Maximus NC, is really our heart of our system here. That Maximus NC gives you the possibility to control the process, to evaluate the process, and to do the documentation of the process. And that's important because then you get 100% traceability. Our device has 128 different kind of programs which are completely independent. That means you don't have to share things with our programs. We have up to 10 evaluation objects for each program. We have a complete different sequence for each program. So this gives you really a high flexibility. Then we have an internal storage of 5,000 curves. which can be used as a spooler. Spooler means if you have problems in your machine with Ethernet, we are able to buffer the measurements in our device. And if the Ethernet connection is back, we can send these data out without stopping the machine. For a flexible integration in the machine and adapting our device to your requirements, our field bus is very powerful and it's flexible because you can do a configuration of our field bus. Then our device is really fast. We have 4 kilohertz measurement range, a measuring range and sample rate between the servo drive and our Maximos NC. This is 250 microseconds, so it's really very fast. And for a force measurement, we have 10 kilohertz. That's a real measuring device. And that helps you a fast reaction and saves you some cycle time too. And for the documentation, we have a lot of protocols integrated in our device, OPC-UR, QDAS, IPM, and CSV, XML, PDF, and we have statistics on board. So that means if you are in the office and I want to take a look at my process, you can look at the Maximos and can check how your process looks like, and also these statistics are in our device and for free available. And everything is included here. So the device is really very good, and you have all this feature buying a system from Kistler here. To summarize that, for sure during the production here and operation, you can save time and you can save money using electromechanical systems here. A better process control can improve your quality and reduce any kind of scrap. And the higher flexibility here by the parameterization could offer you a possibility that one machine is smart and can do different kind of parts on one machine. So the flexibility is given by our systems. And for sure, to ensure the quality, we have integrated statistics and a protocolation, which offers you 100% traceability at any time. So we send all these values out, and important thing is which kind of values we send out. We not only send out the measuring values or the process values, we also send out the set points. So you know exactly if we export data like in our CSV format, that you know exactly which was the calibration value, what kind of position and set point and speeds are used, and what is the result and how the process values looks like. So that guarantees you that it's a complete traceability for you. To summarize now the electromechanical joining system and the advantages is, we as Kistler here, we offer you a complete package. Complete package begins with a consulting, training, and simulation capability at the beginning of your projects. We guarantee with a hotline and commissioning, MSA or cycle time optimization here, that your commissioning works fine. And during your operation, we can offer you emergency stock calibration or maintenance contracts. That helps you to ensure and to improve your production here. Important is here for our NC joining systems is we offer you a high degree of flexibility and traceability for your process. So if you think in a smart factory, that's a tool that helps you to get all these data so to improve the control. The installation efforts are quite easy. The systems are pre-tested and the programming is quite simple. And you save money by less maintenance, by less cost of ownership, and by less energy consumption. And you do for sure something good for the environment too. You have an environmental benefit here. So you remember perhaps that picture at the beginning, oh my God, I have an application, I have problem, I don't know what I should do or how I should handle that. That is our goal, that we take care about you, we help you, we support you, we find the best solution, that you have more time for other things, for your business or for your free time. And we are looking forward. If you have any kind of applications, we would like to help you to find the best solution for you. So now I'm at the end of the presentation. You see here, our products are typically blue. Now it's green because of the environmental friendly issue here. And I would say perhaps we have any kind of questions here remaining.
Thank you, Alex, for the very informative presentation for Kistler Joining System Solutions. There are a few questions from our audience. Do you have a few minutes to answer them?
Yes, it's okay.
First question we have is from the presentation, Kistler offers different types of joining modules. Is the controller different for each joining modules?
No, the controller Maximus and C is a big advantage that everything is on board. That means it's only one controller, independent of which kind of system you use. You have all the interfaces on board. That means you have an Ethernet IP, you have an EtherCAT, you have a Profinet on board. Also in Profibus, you have the connectors for strain gauge, piezo, and active. You have also the possibility, if you want to use an external displacement sensor, that you can add that too. And all these things are on board. And the advantage is for you, you have only one controller, that's it. So that helps you also saving spare part, having only one device. And that was what we really took care about, that everything is integrated and in one powerful device here.
Thank you, Alex. Another question, what are the safety technology offered for different joining modules?
Yes, every safety is important here, especially if you talk about higher force. So as a standard, we deliver every system with safety technology. That means for the cheaper systems like the NCFE, we have a cheaper safety technology. That means at least we have an STO on board here. The other systems, they come with a standard, as standard with a safe limited speed, an SS1 or SS2 up to performance level E. And so also the safe limited speed as a standard of our system helps you during installation or during a service mode here to be more safe. That's why we take care that every system is with safety technology on board.
Thank you, Alex. There are a few more questions, but it is over the scheduled time now. So we'll close the session for now. We will answer the questions individually, and we'll send you emails to answer those questions. Thank you for attending Kistler webinar, Servo Press Efficient Force Displacement Monitoring and Process Control today. Thank you, Alex.
Thank you very much. Thank you for your time. Thank you for your attention. We are looking forward to hearing from you. If you have any kind of questions, and I wish you a great day. Stay safe and bye-bye.